Welcome back. Let us start with the problems related to maximum minima in the view of entrance, that is JEE or whatever you say so. Now before I jump on to this particular topic of maxima and minima, we have already did the problems based on increasing function and decreasing function, then Rolle's theorems and LMVT, everything is in their playlist. Go through that. But before I jump to this particular topic, I would like you to go through the theory of maxima and minima. First go through that theory and then come over here. We know when it is maximum. The maximum is depending on so-called as the values of first derivative. That is, the first derivative, that is the function must be increasing from left to right, and at the point of whatever is the stationary point, up to here it should be increasing, and after the stationary point it should be decreasing. That is the point of maximum, which is found out using first derivative. First derivative gives you critical point, not deciding whether it is maximum or minimum at that particular point. But the second derivative decides whether it is maximum or minimum at that particular point. That means the second derivative, if it is negative, then it is maximum at that particular point, and vice versa. Okay? But as I told you, it is not every time necessary that you will get it using first, second derivative. Sometimes in rare cases we are finding third and fourth derivative also, and the best way is to use the fundamental property. That is, this is your maximum, right? This is your maximum point, this one. So this is your stationary point. So here your f dash x is positive and here your f dash x is negative. That means to the left it should be increasing and to the right of that particular point it must be decreasing. This is maximum and vice versa for minimum. So now as I go through this, I will be explaining in short also all the steps. As I always say, I don't believe in solving it by shortcuts. I actually solve it. So I need to find the shortest distance. To find the shortest distance, I need to know what exactly I have to do. That is, I will see the working plan. For that, I will see what is the question. It says y minus x is equal to 1 is this is one curve, and x is equal to y square is one curve. So this is straight line, no problem, and this is a parabola. Okay, so I would better draw the figure and then I will plan out. I am drawing a figure over here. See, y square is equal to 4ax. So this is this parabola already. Y square is equal to 4ax. So this is your y square is equal to x. So here when you see, it is actually y square is equal to 4ax, and here 4a is your 1. So obviously your a is your 1 by 4. And there is a line which is so called as y is equal to x plus 1. So I will plot this line also to understand exactly how it looks. It does not matter too much, but by drawing it you will get the idea to solve. So here you know probably how to plot this point, but then too I will show you. Okay, when I put here y is equal to 0, so x becomes minus 1, so this is here. And when I put x is equal to 0, so y is over here. So it will be a line this way. This is your y is equal to x plus 1. Okay. Now the shortest distance between this particular curve and the line obviously will be somewhere. That means I need to know a point on the curve where it will be shortest distance. Say here it is, to visualize it. So this is the point P. The working plan says that I will get the coordinate of point P pehle. Okay. To get the coordinate of point P, so I can take any point as so called as HK over there, but that is not advisable. Whenever such problems are there, they are solved using a parameter, because parameter will give you one single variable to differentiate. So we'll use a parameter. The parameter for y square is equal to 4ax, for y square is equal to 4ax, right? Your x is equal to, you already know what is the parameter, but if you do not know, then you already put it and see what should be your parameter, right? So y square is your 4ax is already given to you. So that particular values, now here you have studied in parabola already. Those particular values which will satisfy your this particular equation are the parameter, and obviously we have seen that trigonometry does not satisfy this. So you require a parameter t. Okay, you require a parameter t which is 80 square, and obviously because of this the y becomes 280. That means 280 square, if you see, is your, now see, actually I am showing you, this is not the part of this particular explanation, but then do 280. So this will become 4a square t square, and this is 4a, and x value is already 80 square, that is 4a square t square. So your parameter over here is nothing but p, so called as 80 square comma 280, right, in which a is already 1 by 4. So obviously you will get this p representing 1 by 4 t square comma 2 into 1 by 4 into t, which says that p will represent your t square by 4 and t by 2, right? So I got this point now. Now what is my further plan? That also you think. Once I get this particular point, then I can get the slope of tangent to this particular curve. Agreed? If I get the slope of tangent to this particular curve, then that tangent will be perpendicular to this particular shortest distance. So I will get the slope of this particular perpendicular, or so called as normal. And once you get the slope of normal, then slope of this line and slope of this normal will be that giving you product as -1. So that will give you this parameter t. The working plan is like this. So now when I differentiate so called as y square is equal to x, so you get 2y dy by dx is equal to 1, indicating dy by dx is equal to 1 by 2y. So dy by dx at so called as your y is equal to t by 2 is equal to 1 by 2, and y is your t by 2, indicating 1 by t. So your slope of tangent at point t square by 4 comma t by 2 is your 1 by 2. So slope of normal will be obviously will be equal to minus t. That is, slope of tangent into slope of normal is equal to -1. So that will be equal to minus t. Now you know one thing, that this is a normal. So this is also a line which is normal to this normal. That means slope of line already is here. Slope of line by the equation is 1. Okay. Y is equal to mx plus c. So m is equal to 1. So therefore I know product of slope is equal to -1, indicating t is equal to 1. If t is equal to 1, indicates your point P is now here, that is 1 by 4 comma 1 by 2. Right. Now I know how to find the distance between a point and a line. So distance between a point and a line is given as ax plus by plus c upon under root a square plus b square. Okay, that you have studied already. So this is your line, which is actually so called as here. It is x minus y plus 1 is equal to 0. Okay, so here your a is 1 and b is your -1. So you get here 1 into 1 by 4 plus so called as -1 into 1 by 2 plus 1 upon under root a square plus b square. That is 1 square plus 1 square. That is minus is there. Does not matter. This is -1 ka square. This one which will become obviously your 1 square only. So what you get here is, this will transform itself to this will transform itself to 1 by 4 modulus value of 1 by 4 minus 1 by 2 plus 1 upon root 2, which is nothing but on solving. So I get here, this is, I will better solve it, 1 minus 2 plus 4 upon 4 upon root 2. That is, in short, this will become 5 minus 2. That is 4 and 1, 5. 5 minus 2. That is 3 by 4 root 2. This will be the modulus distance, which is always positive. The shortest distance is your so-called as 3 by 4 root 2. This will be the shortest distance and the easiest way to solve. Now, coming to the second question which I have written already, it says 1 minus x plus x square upon 1 plus x square. What is the minimum value? That is, when the minimum will occur, not minimum value, we can say this particular thing is minimum at what value of x. That is, if we say like this, at what value of x it will become minimum. Okay, that is, and we can also find minimum value, but let us think when it is going to become minimum pehle. It means that for what value of x. So line of thinking will develop pehle. The function of x I have written as, that is, I have taken this particular as function of x, 1 minus x plus x square upon 1 plus x square. If you see this particular this function, what I find is that numerator and denominator is nearly same. The only change is with the sign. So let me make it same. I may get some idea from this. 1 plus x square, right? Minus 2x will be this. Agreed? So I get this. Let me put the bracket over here to understand it better. Okay? So x minus 2x is equal to minus 6. And when I separate it, so what I get here is, this will be 1 minus 2x upon 1 plus x square. This is your function of x. This function of x will have minimum value. This function of x will have minimum value provided the subtraction part, whatever is there, that is this particular part which has been subtracted, that must be maximum. That means I will write with simple logical example. 1 minus 0.1 will give me what? 0.9. But 1 minus 0.9 will give me what? 0.1. And I want this one. Right? That means this must be the maximum possible value for x. Right? Which should be subtracted from 1 so that we get the minimum value. Okay? To get the minimum value, this particular part, that is this 2x, that is for, I can say, for minimum value of function of x, this 2x upon 1 plus x square must be maximum. And once it comes to maximum and minimum, it has to deal with the first derivative and second derivative. So first derivative I can find using quotient rule, no problem. The second derivative also I can find, there is no problem. First derivative I will find and get the critical point. But if I use quotient rule, so I think so I will be getting problem to solve this. So what should I do? If possible, I will remove this x from here. That is, let this be taken as some function p, which is 2 upon, that is dividing by x, 1 by x plus 1 plus x. Right? This will be your p, which should be maximum. Now, if this is to be maximum, I need to get the derivative of this. To get the derivative of this, because if I get the derivative of this, I will get the required critical point. and at that point I will decide by second derivative that it is maximum or minimum. So I can say for a common writing I will say that this is 2y so called as something like k. Okay, it means that k is your now 1 by x plus 1 plus x. I can write here that k is your 1 by x plus 1 plus x. Now let me use logical understanding. This p I want maximum. Okay, if this p I want maximum, so 110% this denominator must be minimum, because if denominator is minimum, the division will be maximum. That means this k value must be minimum. So I can say here कि 1 by x plus 1 plus x must be minimum. Okay, so this k which is there must be minimum. So I am taking it as dk by dx is equal to minus 1 by x square. This is 0 and this is your plus 1. Okay, so you get dk by dx to be as minus 1 by x square plus 1 derivative, and to get the critical point dk by dx must be equal to 0, indicating that 1 by x square is equal to 1, indicating your x square is equal to 1, showing that x is equal to plus or minus 1. Okay, so here I am going to see whether it is minimum or maximum. So I have some space over here. So obviously I will get my second derivative done now. Okay, so I get here d square k by dx square. So obviously it will be d by dx of so called as minus x raised to minus 2. Okay, and plus 1 so I am not writing only because derivative already is going to become so called as 0. Let me write it. Okay, so here I get, now this will become so called as derivative will become this minus and minus, obviously it will make it plus. So this will become 2x raised to minus 3. Sufficient it is, or so called as 2 by x cube. Now 2 by x cube at x is equal to 1, and one more point at minus 1. So at x is equal to 1, first I will take this as 1. So I get 2 by 1, that is 2, which is positive. Which is positive, that means this will become minimum. So therefore I can say here that this particular k is minimum when x is equal to 1. Right? This k is minimum when x is equal to 1. So when x is equal to 1, this k is minimum. Understand now? हाँ? ये k सबसे छोटा हो गया, ये छोटा हो गया, तो डिवीजन जो है 2 बाय छोटे नंबर से, सबसे छोटे नंबर से होगा, तो ये बड़ा हो जाएगा, और वही तो आपको चाहिए कि ये मैक्सिमम होना चाहिए. राइट? दैट मीन्स आई विल से कि दिस पर्टिकुलर फंक्शन विल हैव मिनिमम वैल्यू when x is equal to 1. So therefore function of x will have minimum value when x is equal to 1. Therefore function of x has minimum value when x is equal to 1. I am once again explaining क्या मैंने किया. मैंने ये चीज़ तो आपको समझ में आ गई होगी. मैंने खाली एक ही चीज़ किया. You can go by one more method which I don't want to discuss right now, but I will explain this only. मैंने ऐसे किया तो ऐसे करूँगा, तो 1 माइनस हो गया, बराबर. तो this, तो to reduce so called as calculation मैंने x से डिवाइड कर दिया, तो यहाँ पर डिवाइड करने के बाद I got this thing. Now the discussion phase came over here कि here I want to subtract from 1 something, and as discussed if I subtract the maximum value, ये वैल्यू छोटा हो जाएगा, सबसे छोटा, यानी ये मैक्सिमम होना चाहिए, ये मैक्सिमम, इसका मतलब ये मैक्सिमम होना चाहिए. तो इफ दिस इज टू बी मैक्सिमम, तो ये मैक्सिमम होने के लिए रीजन क्या होता है कि जैसा अभी आप देखो कि हियर इट इज 2, राइट, 2 if you divide by 1 is what? 2. And 2 if you divide by 4 is your 0.5. Agreed? यानी जैसा डिनोमिनेटर बड़ा होगा वैसा इसका आंसर छोटा छोटा होते जाएगा. तो if I want that denominator should be, that is this answer should be big, the denominator must be smallest as possible. तो ये सबसे छोटा होना चाहिए. तो for that obviously I am taking your derivative and getting this xs. तो second derivative I got, and second derivative at 1 I got it as positive. That means it will be minimum if and only if the x का value is 1. तो function of x will have minimum value when your value of x is equal to 1. Okay? Nice. Let us go to another question. Now, come to the next question which I have written. I have written in short, but what it speaks that I will talk about pehle. Polynomial in x is a real polynomial function. Okay, it is real. And it is of least degree. Degree is smallest. Smallest means it will be very small. That is 1 or 2 or so or what it is. Okay. But has what? Local maximum at x is equal to 1. And local minimum at x is equal to 3. That means these are the critical points. Right? So if these are the critical point, then there must be 100% x minus 1 into x minus 3 multiplied by something which would be the derivative of the function, because critical point you get after getting the first derivative. That means p dash x which is there, when you solve p dash x is equal to 0, that means I can say here that p dash x is equal to 0. That gives you this particular point x is equal to 1 and x is equal to 3. So obviously this will be your p dash x which is there will be obviously something like that as k into x minus 1 into x minus 3, because the word is there of least degree. If this word is not there, if it is told cubic or so called as higher order, then the cases will be different. That will deal with that also. But right now the degree is least. So degree is least means not more than 1 or 2. But here already the two critical points are already mentioned. So it could be this. So when you solve this, I am not going further pehle. Let me solve this only. So I get this as x square minus 4x and plus 3. Correct? Yes. This is your p dash x. Right? That means derivative of p will be this thing. Now to get px, that you know very well, if derivative is this, to get px I need to integrate. So therefore I will get p of x is equal to integration of k into x square minus 4x plus 3 with respect to x. Right? So this k let it be outside. This will be your x cube by 3 minus 4 x square by 2 plus 3x plus c. Agreed? So I get this as integration. Finally it turns out to be as k into x cube by 3 minus 2x square plus 3x plus c, which is your p of x. And two values are already mentioned over there. That is p of 1. So here p of 1 will be k into 1 by 3 minus 2 plus 3 plus c. Okay? And this value is already known as how much? 6. So 6 is equal to k into 1 by 3 minus 2 plus 1, that is equal to 1 by 3 plus 1. 1 by 3 plus 1 is equal to 4 by 3. Na? It is 4 by 3 plus c, which turns out to be as 18 is equal to 4k plus 3c. Let this be the first one. And when I take p of 3, so p of 3 will become k into, this is your 3 cube by 3 minus 2 into 3 square plus 3 into 3 plus c. Agreed? So on solving this, we get this, that is c is equal to, this is 0, na? Yes. So therefore we get here k c is equal to 2, and C is equal to 2, that means this is your 6, that means 18 minus 6, 12. So K is equal to 4, K is equal to 12, that is 3. Okay, so you got your C and K also, both you got. So obviously you can get your so-called as this particular polynomial, this is your polynomial. So therefore P of X will be equal to K is your 3 into x cube by 3 minus 2x square plus 3x, and C is your plus 2. Okay, on solving you will get the required polynomial. So as per the required part, we got this particular polynomial. Let me go to the question pehle. Acha, I require P dash 0. Okay, so therefore P dash 0 will be your P dash. Yes, this is your P dash. That is K into, and K value is 3 into 0 minus 1 into 0 minus 3. So that will be equal to 9. Okay, so I get P dash 0 to be as 9, and if the polynomial is asked, that also we have already found out. Now coming to this particular question, if you read the question, it says कि minimum value of sum addition of real numbers, that means these all are real numbers, specifically mentioned that A is positive. Now if this particular thing is there, so recollect कि you do not have any function over here, right? You do not have any function, but you have to just get the addition of them. So addition will be what? That is sum I am writing here, sum to be as 1 by A cube plus 1 by A raised to 4 plus 3 by A cube plus 1 plus A raised to 8 plus A raised to 10. Okay, this is your function of x. Now if you imagine getting it differentiated, first and second, first with the critical point and second for knowing whether it is minimum or maximum, so it will be very tough to solve. So this particular question, if you see it properly, I would take you to this particular one of the concept which I already taught you. Let me write this. This 3 upon A cube I can write as A upon, that is 1 upon A cube, 1 upon A cube and 1 upon A cube plus 1 plus A raised to 8 plus A raised to 10. Okay. Now see, one hint which I am telling you is count the power. 3 and 4, how much? 3 and 4, 7, 7 and 10, 10 and 13, 16. Total is 16. Okay. And this also is what? 16. That means if I multiply all of them, I am going to get 1. Right? So I can get the product of them. Right? This into this, into this, into this, into this. That is, I have to get the product of them. And product I have to relate to addition. So this brings me to the concept of addition. That means I need to add them, and product means I need to multiply them. So addition and multiplication, I will bring it or I will relate it with addition as arithmetic mean and product with geometric mean. So if you go to the playlist, you will find the complete topic explained as root mean square, arithmetic mean, geometric mean and harmonic mean. In that we know that arithmetic mean is greater than equal to geometric mean. Okay. When A is positive, why, that also is discussed over there. Myself is SAMIR sir from SMG Group Tuitions. You can go through that. Okay. So you can go through this and you will come to know how to link that I told you. What I found is that when I add all of them, I get 16, and this also addition is 16. Remember, the number of terms are very important. That is here 1, 1, so I made this also 1, so that I get the number of terms. So I got number of terms as 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8. Total terms are 8. Okay. So arithmetic mean says कि addition of this, that is I will better say S na, okay, S upon 8, that is your arithmetic mean, is greater than geometric mean. Geometric mean means product of this raised to 1 by n. 1 by n means how many terms are there? The terms total are 8. So here it is 1 by a cube into 1 by a raised to 4 plus 1 by a cube into, sorry, here not plus, everywhere into 1 by a cube into 1 by a cube into 1 into a raised to 8 into a raised to 10. The whole raised to 1 by 8. Okay, 1 by n. So that your n is nothing but 8 over here. Okay, so you can see here 3, 4, 10, 16, 16. So it divides off. So s by 8 is greater than equal to 1 raised to 1 by 8. This is the best part of the question. 1 raised to 1 by 8, there is no problem, it will become 1. So here you get s is always greater than equal to 8. That means sum of this particular terms, that is sum of this particular real numbers which are mentioned over here, is always going to be greater than or equal to 8. Means the minimum value over here will be 8 or more than 8. So therefore minimum value of this sum is your 8. Wasn't it interesting? Enjoy with me, but keep your concepts very clear. Then it will be very easy for you to understand. Now, coming to one of the beautiful question. Function of x is given to you as integration of 0 to x, and it is t square into t minus 2 into t minus 3 dt. If you remember, this reminds you of so-called as, if you remember this, it will bring you to the concept of Leibniz. Recollect it. What it says? It is integration of 5a to 5b, t square or t into something something something. So it is nothing but f dash of x will be equal to the Leibniz rule, which I have already written here. Let me explain you in short. Actually it is very big, but let it be, means I have written in the shortest possible way. dy by dx of integration of function of t dt from this limit to this limit. Okay, now if this is I need to write this as ux. Okay, my habit is there of writing gx. So this is ux I have written, and this is vx. So what we take upper limit pehle. So it is function of upper limit into derivative of upper limit. Simple way to remember. Function of upper limit into derivative of upper limit minus function of